That's Wednesday. We already have 2 TPS because we have some practice for some problems. And today we will start some discussion. But before that one, if you still have some question about the 2 TPS, you can send me the messages through the line, and so that I can know that one. And if necessary, I will re-explain the solution to you. And today we will have the discussion about IPv6 and generalized forwarding. Well, why we want to have IPv6? Originally, we have the version IPv4. From version 4 to version 6 only. We don't have the intermediate number. And the original length of IPv4 datagram is 32. Well, why we want to have IPv6? We don't think we have enough addresses, so we want to have IPv6. And so that we have the longer length, 128 bits for the datagram. And additional motivation here, we want to have the faster processing of forwarding. Faster processing of forwarding, how to achieve it? We want to have a short and simple header. Maybe you have a question, 40 bytes, is it short than the original IP version 6? In fact, no, but for the new IPv6, actually it's short, and we don't want to have the, you see, we have the fixed length. We don't have the optional in the header. And also we have the concepts, flows. So this is the reason. I mean, these are the reason for IPv6 to migrate from IPv4 to the current version IPv6. So successfully migrate from IPv4 to current IPv6? No, we expect to have these. Well, therefore, we have the datagram format for IPv6. We have 40. You can count, is it 40? Well, previously, we didn't know we have the short headers. Why it is short? Because we have 128 for source address, destination address. For the two addresses, of course, the two addresses occupy most of the header. But we want to let you know we simplify the header here. So we don't have the other headers in IPv4. We simply have a version, priority, flow label, and length, next header, and hop limit. If you can check this and ignore the addresses, source, and the destination, then you think, is it shorter? Yes, it is shorter than the remaining headers in IPv4. All right, so of course we have 128 IPv6 addresses. And specifically, we call label. So we have the flow label. And for IPv6, we want to have the implementation of priority. So we include priority within the format. Well, after that, I mean, we have the missing parts if we compare with the IPv4. So you see, no checksum, and no fragmentation and reassembly. And specifically, I want to mention, because of the fixed size, this time we don't have options. In IPv4, we have options. For the current one, we don't have options. Well, so the current description, you can notice the longer addresses. And compared to IPv4, we don't have more headers. Actually, we have shorter headers excluding the addresses. Well, so this one actually meets the requirement for IPv4. We have the longer addresses. We want to make it simple, and so that we can have the faster processing and forwarding. Well, of course, you know, if we want to have the transition from IPv4 to IPv6 completely, you can check currently, is it true? No. And later we can let you know the percentage of IPv6 currently. However, at this, we expect to have the transition from IPv4 to IPv6 if we think IPv4 is a new version. Well, actually, here we don't know the status. No flag days. What that means, flag days, later we can check for you. And actually, because of no flag days, so we should have the mixture of IPv4 and v6. So you see, mix IPv4 and v6 routers. They should coexist. Well, I don't know two key terms before we have the further discussions. Flag day here. And the tunnel. So no flag days, that says we don't have any chance for IPv6. And they should coexist and work together. And work together, how they can work together? We have the specific technology we call tunneling. And we didn't know the keyword tunnel previously. We have, for example, in the highway, possibly the car will pass through the tunnel. Within the tunnel, why we want to use tunnel for the current discussion? We think going through the tunnel, then don't care too much when car going through the tunnel. Likewise for this, and we want to have a concept like that. Why? IPv4 and IPv6. If currently we have the protocol IPv4, carry IPv6, and then should we care about IPv6 in the protocol of IPv4? No, we don't care about that one. And maybe you have a question, should we reverse it? Oh, IPv4 carried by IPv6. No, currently we assume we have IPv6 originally. And we want to go to the domain of IPv4. So for this one, we will have the concept put IPv6 datagram into the payload of IPv4. And this kind of operation is tunneling. Why it's tunneling? Because we have a box of IPv6 contained within the box of IPv4. And if we have any stamps on the outside of the box of IPv4, should you care about the content of IPv6? No. And so that we can avoid IPv6 details and carry within the network of IPv4. All right, so currently I have the concept that I know is tunneling. All right, maybe let me speak a few Chinese for you. 我们其实把 IPv6 看成是一个箱子，小箱子放到一个 IPv4 的大箱子，放到 IPv4 大箱子，我们可以用 IPv4 的任何的目的地贴上标签，送到目的地，或者送到哪一个地方。那请问要不要管 IPv6？ 不用。但我还没说的是，IPv6 如果真的要拿出来，那怎么办？那就把它取出来。So I don't know in Chinese about the tunneling. We have two boxes, box of IPv6 and box of IPv4. And so that we have this. In fact, datagram is described in box. And so that you will have the concept, put the box and put the datagram of IPv6 into the box of datagram of IPv4. And this operation is called tunneling. Well, you can feel, is it true? This is the behavior of tunnel or tunneling, actually similar to tunneling. So that's why we use tunneling for the current technique. You see, IPv4 datagram carry us the payload in IPv4, and so that it's tunneling, and so that you won't be necessary to care about the details for IPv6 in the domain of IPv4. Well, you can check it, and we have the standard. And actually IP, so IP for some of our network, for 4G and 5G, they have a tunneling as well. It doesn't mean that tunneling for the current operation, IP in IP. So the current tunnel, we can have the specific name. It's called IP in IP tunneling. All right, so why I want to mention this explicitly? Because of the current tunneling, in fact, it's the IP in IP tunneling. However, in 4G or 5G or the other telecommunication, they still have the concept of tunneling. But it doesn't mean they use IP in IP tunneling. Maybe they have the different packets or maybe different datagram, then they will have the tunneling as well. So we want to make IPv4 and IPv6 router work together. Then we need to use the concept or the technique of tunneling. Well, currently we have tunneling, and we want to put it into the box. So it is called tunneling and working with the concept of encapsulation. Encapsulation means putting boxes into a box of IPv4. So here we have IPv6. And if within we don't have any IPv4 router, so here is tunnel. Right? We have a tunnel going through the domain of IPv4 routers. However, if we want to have more details than this one, indeed, we have a domain of IPv4. And here we have the operation of tunneling. Then it says, oh, we need to convert the protocol from IPv6 to IPv4. And then we use IPv4. And this one convert from v4 to v6. And then forwarding through the domain of IPv6. So previously we put the box of IPv4 into IPv6 into IPv4. It's tunneling, and then it's the encapsulation. And in fact, we want to extract and then going through the remaining IPv6 domain. So encapsulation and decapsulation, working with tunneling, then we can finish the operation in the two domains, IPv6 and IPv4. So we don't have the specific description, but look at this. We have a logic view. Because of tunnel, so even it's IPv4, we don't care about that one. Within IPv4, we don't care about the content of IPv6. And for IPv6, because we know it's tunneling, so we don't care about how our IPv4 carry the data for IPv6. However, if we want to know, oh yes, we have IPv4, and then what it operates exactly. You see, we have the way put IPv6 datagram into the payload of IPv4. And this one, we want to have the conversion from version 6 to version 4. All right, if version 4 ready, then we can use IPv4 router, and so that we can reach we can use V4 and V4 and V4 here. And for this side, put the IPv6 datagram into the payload of IPv4. It's encapsulation. And going through IPv4, right now we want to extract IPv6. So extract is decapsulation. Decapsulation, then we have IPv6 again. IPv6 again, then we can go to the destination within the domain of IPv6. If we assume it is a scenario like this. All right, so this is the details of tunneling, and it's IP and IP tunneling, and so that we can allow IPv4 and v6 router coexist. Well, about the current concept, allow you to have 1 minute to think about this. So about tunneling, any questions? It should be okay, right? So let me go forward to the next one. Well, so up to now, I didn't have the concept because of initially we think it should be the shortage of IPv4 addresses. Therefore, we have IPv6. And because of no flag days or the other reasons, then we need to ask IPv6 and IPv4 coexist. So we should employ the technique of tunneling. Well, up to now, if so, then because of no flag days, and so that we think, what is the percentage of IPv6 currently? That says, we can check if we use Google, for example. Currently, about 30% of client access via IPv6. Near 1/3. Why I ask you to think about near 1/3. Because of this. So 30% near 1/3. So for Google, here is NIST, almost the same. If we use 1/3 to represent so approximately just 1/3. So we can continue. All right. Initially, we try to have the promotion for IPv6 around year 2010. And up to now, only 1/3. Yes, you can see it's really hard to have further promotion. Of course, we have the adoption of IPv6 here. And up to now, only 1/3. Well, you can think about, yes, because of no flag days and also the other reasons. So, we want to ask you to think about this. It's a long time, or it's a long story, and so that it's hard to have the deployment completely for IPv6. So it's hard to have this. And currently, you count the duration, 25 years, not really easy. All right. In fact, we have the deployment since year 2000 and currently we have 25 years. And why you think it's hard to have the migration completely from IPv6 to IPv4 to IPv6? Because we are familiar with all the operations, and also if you want to change, it costs much, possibly. So we don't want to change. And why we don't want to change? Because we have the technique of NAT. NAT, then we still think it's okay. We won't have the original problem of shortage of addresses. Well, so this is a current discussion about IPv6. I think you understand the core concept of tunneling because of the coexistence of IPv4 and v6. All right, so this is IPv6 for your reference. And in the following, we already have the event of attendance checking. And of course, if no problem, you use the system so that we can collect the attendance records for all of you. And let me have this for you. Likewise, 2 minutes for all of you. All right, so 2 minutes for you. Therefore, I can leave this and so that go to the next page. Well, we finished the discussion for IPv6 here. And the next one, we will talk about the generalized forwarding. And this one. And after generalized forwarding, we will have middle boxes and some discussion in TPS, talking about fragmentation and reassembly. Well, let us check generalized forwarding now. In the past, we have the forwarding. It's the destination address forwarding. Based on destination address, we know how to have the forwarding. And so that we have the setting for the forwarding table. That one actually is one of the possible options for the current generalized forwarding. If we want to do that, how to have the generalized forwarding? We want to base on match. So we can have a match, and so that we will take the action. For the original destination address, we can match the destination address. Then we have the action, which port to forward. Well, so we can have match and action. Well, match and action, then is it enough? Yes, it's enough. This one actually can include the previous one, destination address and the forwarding. You see here, this is a destination address. We can check the header if match, for example, the longest prefix matching, right? The longest prefix matching, then we can have the forwarding. Well, however, only this one, no. We want to have the generalized forwarding, so of course not that one. We have the extension. How to have the extension? Of course, not based on the original or the traditional one. We want to use the SDN, so here we have the architecture of SDN. And of course, previously we have the destination-based forwarding. Right now we have the generalized one. And generalized one, in fact, we can have more services or more actions. We have the forwarding only. But right now we can have the other possible actions. We can drop, we can copy, we can modify, of course, we can forward for sure. And actually, we can have the other actions. About the pattern. About the pattern. So the pattern only destination address. No, we can have MAC and the other. And even now address, we can have the new pattern. If we have the selected pattern and some possible action, then we can extend the current destination-based forwarding. So this is the purpose of the generalized forwarding. And for the generalized forwarding for SDN, and for SDN, then we can have the flow. So we change the forwarding table to the current one flow table. And we have the flow table abstraction. What that means, abstraction. This is a key word here. All right. That says it's a concept. Well, we want to have the flow table abstraction. We need to have a match pattern and the action taken. All right, so you see, I let you know the key term, pattern. Pattern here, and the pattern value match in the header for sure. And in the header, and you can find which pattern you want to match. And suddenly you have the action. Drop, modify, and something else. Of course, previously we don't have the term, but in fact, we should have the term forward. This is a necessary action, forward. And beyond forward, we still have the other actions. Drop, modify, and something else. And actually, we can have the setting of priority as well. But currently, we want to emphasize priority. But at least we already have priority. And also, we can count something. We have the counters. And likewise, for your reference, at least we already have the pattern match action taken. So at least we have the two ideas. As for priority counters, later we can check them. Or maybe if necessary, you can check them further. Here we have this one. If we have source destination given like the example here, and we have a wildcard. Wildcard means, okay, any value will be accepted. So we give you these. And we assume, first of all, this is the first pattern and action. We can pass on the given address from the source, any source, to the destination here. We have a 3.4 point the others. So if so, then we are allowed to forward to pole number 2. So this is the first example, match and the action. And the second one, coming from the source address 1.2 to any addresses, then someone like, we have the malicious attackers from the address here, and then we need to drop. And because of SDN, then we have the concept of a controller. So from this source to any destination, then we should go to the destination go to the controller for further processing. Well, here at least we already have the 3 examples. For the 3 examples, at least we have more actions, not the forwarding only. And also we can have the different patterns we want to match, and so that we can have the corresponding action to be taken. Well, so why we want to have the generalized forwarding? Of course, we want to have the generalization for SDN, and the SDN actually will be implemented by OpenFlow. So we have the name OpenFlow to stand for SDN, to stand for the concept we want to talk about, the current generalized forwarding. And for OpenFlow, of course, we use the flow tables. And for the flow tables, we have the pattern to be defined. And what's the possible way to define the patterns? In fact, we can have the layer 2 address, layer 3 address, and layer 4 summarize information of layer 4. It doesn't mean the address. Yes, we have an address for layer 2, address for layer 4, but we don't have the address. We just have the pole number. So pole number of layer 4. And of course, we have the input pole. All of these can be used to have the pattern. At least, it doesn't mean addresses. So we just there you have second layer, third layer, and fourth layer information. And previously, we focused on network layer. All right, and right now we can have the extension. Not network layer, we can have the data link layer. We can have the transfer layer. And in fact, previously we have a transfer layer. And about actions, not forwarding only, we can have a drop, modify, and the others. Well, we already have match plus action, then that's all? No. Previously, we already have the counters. And counters, then you can have the statistic of package bytes counter, and so that you can do something for maybe for the flow table. Well, again, because of the generalized pattern to be defined, then we can have first of all check, is it okay to have the destination-based forwarding? It's true. Here, destination address, so destination. And in fact, we already have the previous information. Second layer, so we have switch pole, MAC source address. MAC destination address, and Ethernet type, and VLAN ID, virtual LAN, and we have IP source address, IP source destination address, and we have the port and TLS of IP, and because of priority of service, and the others. And we have a destination-based forwarding, so we can set IP destination. For example, we want to have the destination of this IP address, and for the current table, it should be forwarded to port number 6. So this is the match and action to be taken. So the specific setting for destination and port number, then that's done. So that is the destination-based forwarding, the traditional one. And now we want to have the possible action at a firewall. At a firewall, then it says we can treat anyone using port number to the destination port 22. Then it will be blocked. All right, be blocked. So it's the possible action taken by the firewall. So we can block any packet data going to the destination port 22. So blocked. And we can have the operation, so blocked, right? And we can have the similar operation by the firewall this time. All right, we think from this address, it's the address in the blacklist. So same, dropped. All right. Of course, we can have the others. We just let it know we can have this, and this can have the implementation for network operation, including the firewall, not the router simply. So of course, we think it's enough for the service provided by ICN using open flow. So here, this is a function of open flow. And we have the normal networking operations using layer 3. And currently, if indeed we want to emphasize, how about layer 2? And yes, layer 2, we can have the MAC address. It says, we want to have the forwarding to the, for example, to the specific switch. To the specific switch, then we can set, destination MAC address there. And then you can have the forwarding to port 3. So in the previous discussion, we only have the forwarding maybe layer up to, above layer 3. But currently, we can have a layer low to layer 2 only. So it's possible to have the forwarding for switches. All right. So of course, it's okay for router, right? And currently, we enable the forwarding for switch. And of course, we can have a generalized function for firewall. And actually, it's okay for NAT as well. Therefore, for the previous forwarding, we think it's only for the router. But right now, we can have all service for routers, switches, firewalls, and NATs. So we think it's okay, and this generalization can provide necessary service for networking. So it's good. All right, so this is the concept of generalized forwarding, and generalized forwarding actually it is provided by OpenFlow. Well, if so, even we have an OpenFlow, even we have at least match plus action, then we can have the forwarding. Let us take a look at the example using the generalized forwarding. We should have the flow table, all right, and so that the flow table can provide the service for us. And right now we think we want to do this. Datagrams, here we have a host H5 and H6. And currently, we want to do these 5 and 6 send to H304. And we ask the forwarding table or flow table go through switch 1 to switch 2. So if we have the rough requirement, then what to do? This is a way H5, host 5, and host 6. Currently, we have switch S3. We are asked to go through S6, of course, S1, and of course to the destination H304, it should go through switch S2. So at least the current path, and the current path here, 6 to 3, that's okay, and 6 to 4, it's okay, and likewise 5 to 3, and 5 to 4. All right, so meet our requirement, it's correct. And later we will pass on the previous principle, match and action to describe how we achieve it. But before how we achieve it, previously we have the key term, this one, provide you for reference, and later we can have the detailed discussion for this one. All right, so up to now, we have the description. So we have the initial description for IPv6. That have the reason why IPv6 and we want to have the coexistence with IPv4. So we have a tunnel. And after that one, we have the description of generalized forwarding. And later we will continue. So this is the discussion for the class. Any questions? If no, take a rest.